All right. First 4 of your warm-up, like I said, you'll have 8, so save yourself a little room. Make sure you're showing work on all of these. If you'd like credit, you need to be doing the work as well, not just blankly staring until an answer appears. Number 1, if these sides are congruent, what do I know about the angles opposite the sides? They're also congruent. Good. So if this one is 52, what's this one? 52. Good. So your answer for the first one is 52. Now, something like that, of course, just 52 would be enough. But whenever I start showing work, make sure you're showing work too. All right, same idea on number 2. We have 2 sides that are congruent. So the angles opposite those sides are congruent. So if this little guy on the top is 20 degrees, this little guy down here is also 20 degrees. But that's not the angle we're looking for. We're looking for this big angle. So what can I do to find it? Yeah, you subtract those 2 angles from 180. So 180 minus the 2 that you know will give you the one that you don't know. What's the answer?
We got to draw that figure. 140.
Yep, that's right, 140. You don't have to draw the triangles, but like you should have this part on your warm-up. So yeah, you don't have to put the problems every time, but if I'm doing work, you should be doing work as well. All right, so those are the only ones we're going to look at where we're talking about missing angles. Any questions? All right, number 3 follows that same idea, but now we're talking about the side length. So if the angles are congruent, the sides opposite are also congruent. So what is L? 5.2. Wonderful. That is all the stuff we did before we did the radical stuff. Then we took a break, did some radical stuff, and then we came back Monday and started 4-4, the Pythagorean theorem. So for number 4, I need to use the Pythagorean theorem to find the missing side of this right triangle. How should I set this up? Remember, we're talking about a squared plus b squared equals c squared. 26 is the which one? A, B, or C? It has to be the C. The longest side is always the C. So that means 24 is the A, and then B is going to stay B.
What are we doing? We doing radical right now?
This is the Pythagorean theorem. So we're going to have to do a square root at the end. All right, what is 24 squared? $576 plus b squared equals, what's 26 squared? 676, okay. I think we've done this one before. It works out pretty nicely. I need to get the b squared, whoops, gave away the answer. I need to get the b squared part by itself. So when I subtract 576 from both sides, I get b squared equals what? What's 676 minus 576? 100. And then we take the square root to get the b by itself. So what does b equal? What's 10? Very good. The square root of 100 is 10. What are your questions on the first 4 on the warm-up? Now, we have some extra warm-ups today. These need to be on your warm-up sheet. If your warm-up sheet is full, go grab another one or squeeze it into the back. But if you want credit, you gotta show work. Questions on the first 4? Okay, moving right along. Here are the next 4. We'll jump right in. Just do these together. Number 5. How should I set this one up? A squared. The 34 has to be the what? The C. So you want the 34 squared on its own. So the 16 squared is your B. Your B part. All right. Now you just start doing some math. What is 16 squared? 256. and 34 squared. I'm getting 1156. Anyone agree? Alright, this one should work out nicely as well. When we subtract 256 from both sides, I get a squared equals what? 900. Can you take the square root of 900? Of course you can. Is it going to give you a whole number? It does. What is it? 30. So A in this case is 30. Good. Remember, if you do not get a whole number on these, we're rounding to the nearest tenth. So you want one number after your decimal. Questions? All right, number 6. Same setup, but we are now finding the C squared. So I can do 14 squared plus 16 squared equals C squared. 14 squared is? 196. Good. We just did 16 squared. We got 256. Those are on the same side of the equal sign, so you can add them together. I'm getting 452. Can anyone confirm?
Yeah.
All right. And then how do I find C? Take the square root. Good. I do think you get a decimal on this one. What is it? 21 point. I'm getting a 26. So the 6 makes the 2 go up to a... The 6 makes the 2 go up to a what? A 3. So it's going to be 21.3. It was 21.26, right? And then a bunch of other stuff. So you look at the 6. The 6 is going to make this one go up just one digit. So the number right above a 2 is a 3. So that's how we rounded this one. Remember, 5 or above, it rounds up. 0 through 4, it just stays the same. Questions? All right, and then these last two, this is what we did the day before, that nice little day off. We're using the distance formula. For the distance formula, you take the x's and you subtract them, square it, add that to whatever you get when you take the y's, subtract them, and square it, and then you take the square root of the whole thing. Easiest way to start this is to label them x1, y1, x2, y2. So I'll set up 7 and then we can set up 8 together. So 7, we will have -2 minus 1, those are your x's, square it, plus my y's, so 5 minus 1, square it. Now, there's multiple ways to do this. You could do it step by step like I'm going to do on the board. You could type it all in the calculator. You could type it all in the calculator besides the square root and take the square root at the end. It is up to you. Just remember to pay close attention to parentheses if you are relying heavily on your calculator, but I will not. I will do it by hand. That's going to give me -3 squared plus 4 squared. -3 squared is -3 times -3, which is +9. 4 squared is 16, and I take the square root. 9 plus 16 is 25, and the square root of 25 is 5. So the distance between those 2 points is 5 units. What are your questions? All right, number 8, we want to do the same thing. I'll write it below it so you can see it. x1, y1, x2, y2. So what do I want to start with? What's my x2? Negative 2 minus, what's x1? 5. I'm going to square it. Plus, what's y2? Minus, what's y1? Very good. I'm going to square it. That's going to give me negative 7 squared, which is 49, plus 4 squared, which is 16. 49 plus 16 is what? 65, and then you take the square root. What's the square root of 65?
8.06.
8.06?
8.1.
8.1. Wonderful. All right, lots of warm-ups today. Getting some good review in. You do have a test coming up. It will hopefully be the day before Thanksgiving, if nothing comes up between now and then. What are your questions on these 8?
Next week is Thanksgiving.
No, we have a full week and then Thanksgiving. Yeah. But we still have 2 sections to do, plus some review and the notebook quiz, and we got some stuff to do. So I'm hoping to get it in before break. Here is what we're working on today. So it is the converse of the Pythagorean theorem. So lots of a squared plus b squared equals c squared. We're actually going to put the c in the front today. C squared equals a squared plus b squared. It's the same thing. But either way, this is called the converse of the Pythagorean theorem, what we're going to cover today. It's going to be a lot of talking about classifying triangles by their side lengths. So a little bit of 4-1 meets Pythagorean theorem, which was 4-4. Oh yeah, typically we call it the objective. On your notebook quiz it will say objective. Sorry, sometimes I put goal, sometimes I put objective. So let's just stay consistent. This is the last day of notes for this week. Tomorrow we're doing a review. Then 2 more sections of notes. And this chapter's done. So then we'll start all the end of the chapter stuff. Alright, you need to make sure you have this chart in your notes. I also wrote a little a cheat sheet over on the board that kind of simplified it. But basically we are using a variation of the Pythagorean theorem to classify these triangles. So you'll see this middle one, this is just the Pythagorean theorem, but the c squared part's in the front. It's just easier for today's problems if we do the c squared in the front. It's the same thing though, if you want to switch them around. It doesn't really matter to me. But if c squared equals a squared plus b squared, then it's a right triangle. That is the converse of what we talked about on Monday. Monday I gave you this information. Here's a right triangle, and you use this to find the side lengths. So remember, a converse, you just flip the if and the then. So this is the if and the then flip-flopped. If a squared plus b squared equals c squared, you can say it's a right triangle. So this middle line is the easiest.
We learned this on Monday.
We learned this line on Monday. All right, we're going to take it a step further. We are saying if you do all the math and the c squared side is smaller than the a squared plus b squared side, that means the side length is smaller. If the side length is smaller, that forces the angle to be smaller than a right angle, and we have an acute triangle. It also works the other way. If you do all the math and the c squared part is larger than the a squared plus b squared part, that means that this side length is a little larger than if it was a right triangle, which means the angle is a little larger than if it was a right angle. Larger than a right angle means it would be an obtuse angle, so we have an obtuse triangle. So we're going to set all of these up the same way. We're basically going to start with this equation right here. If they're not equal, we decide, well, is the c side less than the a and the b side, or is the c side greater than the a and the b side? So you need to know what these symbols mean. That's what this little note is on the bottom. Remember, it's kind of like back in grade school, the big mouth opens towards the the larger side. So just remember that. If you can master this chart, you will do just fine on today's lesson. Any questions so far? Bless you. All right, you don't need to write this in your notes, but this is basically how we're going to set all of these up. So we're going to start with the Pythagorean theorem, the c squared equals a squared plus b squared. We're going to plug in the side lengths and do the math. The main thing you need to remember is that the c always is the longest side. And then once we do the math, if they're equal, we say it's a right triangle, and then depending on which side is greater, we either say acute or obtuse. So you don't really need this in your notes. This is directly from that chart, but it is just nice to look at how we're going to set these up. Any questions before we get going? All right, you don't need to write these two down. I just want to show you basically kind of the strategy on these, and then we'll write down the next slide. So you can just put your pencils down, watch, and soak it all in. So it says, is this a right triangle? Basically. And I'm going to take it a step further. If it's not a right triangle, what type of triangle is it? All right, so we need to start with the basic Pythagorean theorem, which is c squared equals a squared plus b squared. Which side has to be the c squared for today? 13. So 13 squared equals 5 squared plus 12 squared. If that's true, it's a right triangle. If it's not true, we're going to say what type of triangle it is. All right, what is 13 squared? 169. Good. What is 5 squared? What is 12 squared? Whoops. That's a plus sign. 144. What is 25 plus 144? Is it 169? So, they're equal. When c squared equals a squared plus b squared, it is a right triangle. So you can either say yes, or you can say right triangle. I'm just going to stick with, well, what type of triangle is it? But technically the question says, is it right? So you would say yes. Or yes, it's a right triangle. Questions? All right, let's start on B. So same setup. I need to start with the largest side first. So c squared, which is 10. So 10 squared equals 8 squared plus 9 squared. What's 10 squared? 100. What's 8 squared? 64. What's 9 squared? 81. What is 64 plus 81? 145. So, can I still put the equal sign here? No, they're not equal. What symbol would go here? The less than symbol. So, is this a right triangle? No. So, I'm going to first put no just to answer the question. No, it's not a right triangle. Let's take it a step further. What type of triangle is it? It's acute. Yes, when the A and the B side adds up to be more than the C side, it is an acute triangle. What are your questions? No questions? All right, write these 3 in your notebooks. Leave a little space underneath so we can do some math. So again, it's asking, is it a right triangle? Again, I'm going to take it a step further. You can say yes, right triangle, or you can say no, and then tell me what type of triangle it is. Alright, so I'm always going to start as if it's a right triangle, and then I'll just determine which one it is if it's not, okay? So for the first one, I'm going to start with the 37 squared equals 12 squared plus 35 squared. Now, I told you all you would need calculators. Hopefully you still have them. What is 37 squared? Very good. What is 12 squared? What is 35 squared? 1225. Good. If you want to do this whole side on your calculator, that's fine. I don't really need to see this step, but what do you get when you add those together? Yeah, you get the same thing. So is this a right triangle? Yeah, so I'm just going to say yes, right. Alright, same setup for the second one. I'm going to start with the longest side, squared, equals the shorter two sides squared and added together. What is 20 squared? 400. What is 17 squared? 289. And 289, what do you get when you add the 289s together? 578. So really I shouldn't put the equal sign anymore because I know they're not equal. So if they're not equal, is it a right triangle? No. What type of triangle is it? If the AB side is bigger than the C side, what type of triangle is it? Huh? Acute. Very good. Questions? All right, same thing on 3. So we're going to start with the 30. We're going to square it. Equals 18 squared plus 24 squared. That's going to be what? What's 30 squared? 900. What's 18 squared? 324. What's 24 squared? 576. And what do you get when you add those together? 900 equals 900. So is this a right triangle? Yes, yes, right. Great. What are your questions? All right, your homework tonight is actually a lot more like this type of problem. So it's going to say, show that the triangle is whatever. It's going to tell you which one to start with. So if we are trying to show that a triangle is acute, what should I start with? What do you think? I know it's going to be acute. Sure, the numbers. If you know for sure it's going to be acute, start with the inequality for acute. Alright, so we know that the C side should be less than the A and the B side if it's acute. So if it tells you what type of triangle it is, start with that inequality or equation. Alright? So I know it's going to be acute, so I know this should be a less than. Any questions? Alright, so what goes in for C? C always has to be the longest. Alright, so I need the 20 over there, and then the 14, and the 18. So we just have to work it down to a level where we know that the C side is less than the A and the B side. What is 20 squared?
400.
400. What's 14 squared? 196. What's 18 squared? 324. And what do you get when you add those two together? 520. So I just showed that the C squared side is less than the A squared plus B squared side. That's all you have to do when it says to show it. There isn't really a final answer. You're just, the whole problem is the answer. We're just showing that it's true. Okay, and number 5, now I want to show that this triangle is obtuse. So what should I start with? C squared. I know it's obtuse. Greater than A squared plus B squared. So again, when they tell you what the end game is, just start with that setup. And that's right from the table that you wrote down at the beginning of class. What needs to be the C? 29. So I'm going to say that 29 squared is greater than 11 squared plus 20 squared. I know 11 squared is 121. I know 20 squared is 400. I do not know 29 squared. Can anyone help me out? 841. Okay. So 841 is greater than 521. Is that true? Yeah. Then we just showed that that is an obtuse triangle. Pretty easy, right, when they tell you what the answer should be? Yeah. What are your questions? All right, there's one other type you will see tonight, so I'll show you one of those. And then I'll let you have at your homework. Are we good? I can't tell if you guys are writing a problem or just holding your pen. All right, we're just going to do 6, so you can forget about 7 and 8. These are kind of like the first ones we did, but instead of a picture, they're just giving you the side lengths. So I want to determine what type of triangle it is based on these side lengths. You can't just guess. You got to do the math. So which one has to be the C? C is always the biggest one. So just start with putting them equal until you know otherwise. What is 15 squared? Alright, 9 squared, that's an easy one. 12 squared, that's an easy one. What do I get when I add those together?
You get
81 plus 144 is what? 120, 225?
Yeah.
Very good.
That's why you
So what type?
Right.
It is right. It's a right triangle. Good. Alright, so you can see these are all pretty much the same. It just depends how you're going to set it up. Okay, so if you don't know, or if you're trying to show that it's right, just start with them equal. If you do know what your end game is, if you know it's acute or obtuse, start with that, that inequality and just show that it's true. What are your questions on this section? Alright, so let's take a look at this homework just to get you guys started. We can do 1, 2, and 3 together. And then I'll just kind of describe what they're asking in each section. So number 1 says if you have triangle ABC with the longest side being C, C squared blank, A squared plus B squared, then it's acute. So do we want less than, equal to, or greater than for acute? Less than. Alright, number 2 is the exact same setup, except now it's saying it's right. So what symbol goes in between the C squared and the A squared plus B squared if it's a right? Equal. And then obtuse? Greater than. Okay, so those are directly from your chart. Now, I'm just going to help you set up the rest of them. So 4 through 6. The directions say, show that the triangle is right. So what are you going to start with on all of them?
square.
Like all of them. What formula are you using? C squared. They're right. They're right. Equals A squared plus B squared. So 4, 5, and 6, you're just showing that they're equal. 7 through 9, you are showing that they're acute. So what are you going to use now to prove that they're acute? The less than version. Good. Whoops. And then 10 through 12, you're showing that they're obtuse. So what should you be using? Same thing, but greater than. Good. And then 13, 14, 15, you don't know. So just start with it as equal. And then narrow it down from there depending on what each side equals. 13, 14, 15. Those are kind of like the ones we did in the notes where you don't really know and then you decide at the end. But for 4 through 6, you know it's going to be right. 7 through 9, you know it's going to be acute. 10 through 12, you know it's going to be obtuse. And then 13, 14, 15, you're trying to decide which one. Okay? Any questions?
Oh, what about 16? Let's do the same thing
For which one?
for 16.
16, you're going to have to do that one on your own. A little problem solving. So if this was my homework, I would write this next to the directions for these sections so that when you leave here, you don't forget what you're doing. All right, any questions?